The launch of Meta's Rayban display AR glasses marks a significant moment in the evolution of augmented reality technology and its commercialization. This event is not merely a product release, but a signal of the growing intersection between human-computer interaction, artificial intelligence, and wearable computing. With AR devices, the vision is to integrate digital information directly into our perception of the world, creating a seamless interface between reality and digital augmentation. The rapid sellout of these glasses and the soaring resale prices in global markets, particularly China, reflect both the pent-up consumer demand and the broader excitement surrounding AR technologies as the next frontier in computing. Meta's strategy demonstrates a convergence of long-term research investment, marketing, and a carefully orchestrated rollout. From Oculus in 2014 to Reality Labs and the neural band technology, the company has cultivated a decade-long pipeline of innovation aimed at achieving consumer-ready AR products. The glasses are not only a reflection of hardware sophistication, but also of software and AI integration, enabling intent-based interactions that read subtle muscle signals to manipulate digital content. This new interface paradigm has the potential to transform entertainment, productivity, education, and social communication, essentially extending the digital layer of human experience into everyday life. However, beyond consumer enthusiasm, this launch provides an important case study for AR market dynamics, pricing strategies, supply chain constraints, and the emerging global competition in AI-enhanced wearable devices. The market reaction, from rapid sellouts to high resale markups, illustrates the economic and social dynamics of early adoption, highlighting both opportunities and potential risks. As we explore each slide, we will delve into the market frenzy, technical capabilities, historical R&D context, and future implications of Meta's AR glasses, situating this launch within the broader trajectory of AR and AI convergence. The launch of Meta's Rayban display AR glasses represents one of the most notable consumer technology events of 2025. Priced at $799 at retail, these AR glasses sold out globally within 48 hours, signaling extraordinary demand and significant anticipation. In China, resale prices have soared to over 16,000 yuan, $2,200, a markup of roughly 150% above the original price. This rapid price inflation highlights the scarcity effect, consumer willingness to pay for early adoption, and the cultural perception of AR devices as luxury tech products. The glasses embody the convergence of hardware innovation and software intelligence. Powered by a single-eye LCOS display with waveguide optics, the device delivers 600 by 600 resolution at 5,000 nits brightness, ensuring visibility even in sunlight. These technical specifications are complemented by the Meta neural band, which captures surface electromyography (SEMG) signals, enabling the user to control the interface via subtle finger gestures or even intent-driven commands. The interface design allows for a mind-like interaction, in which the system interprets intention directly, reflecting a leap in human-computer interface paradigms. From a market perspective, the sellout is remarkable, not only because of the rapid depletion of inventory, but also due to the ripple effects across global supply chains and secondary markets. Retailers worldwide have struggled to maintain stock, while resale platforms in China and other regions report extraordinary markups and a flourishing ecosystem for short-term rentals. For instance, in China, rental services now charge 600 yuan per day just to experience the glasses, reflecting the intense desire for first-hand engagement with cutting-edge AR technology. This trend underscores the broader dynamics of scarcity, perceived value, and social signaling in the early adoption stage of transformative technologies. The sellout also demonstrates Meta's success in marketing and anticipation building. The company has leveraged its decade-long R&D investment to establish credibility, ensuring that consumers perceive the glasses as a culmination of persistent innovation rather than a gimmick. The release timing, strategic partnerships with retail outlets, and global communication campaigns have amplified awareness, leading to an unprecedented spike in demand within just 2 days. This initial surge in adoption will likely inform future production planning, global distribution, and pricing strategy, while also signaling to competitors the market potential of high-end AR devices. From an investor perspective, the launch validates Meta's long-term strategy of combining AI, wearable computing, and human-computer interaction. The market's response, both immediate sellouts and inflated secondary market prices, demonstrates the commercial viability of AR devices as high-value consumer electronics. However, it also presents challenges. Maintaining supply, managing consumer expectations, and ensuring that early adopters have a positive experience are critical to sustaining long-term engagement. The short-term market euphoria must be tempered with strategic planning to avoid reputational risks associated with stockouts, delivery delays, or technical performance limitations. In summary, the first slide emphasizes the unprecedented demand for Meta's AR glasses, the market frenzy resulting in inflated secondary prices, and the broader implications for early adoption dynamics, consumer psychology, and Meta's positioning in the AR ecosystem. These factors collectively signal the emergence of AR as not just a niche innovation, but a mainstream technological and economic phenomenon. The immediate aftermath of the Rayban display, AR glasses launch has been characterized by a remarkable market frenzy. Within just 2 days, stores across multiple continents reported complete sellouts, reflecting both successful marketing and the pent-up desire for new consumer technology experiences. Meta has responded by expanding demonstration centers and increasing engagement with retail partners to address the overwhelming demand. In some cities, consumer appointments and demo experiences are booked well into November, demonstrating the intensity of consumer interest and the scarcity-driven perception of the product. In China, the frenzy has taken on additional dimensions, where resale platforms exhibit extreme markups. Prices escalated from the original 5,800 yen to as high as 16,000 yen, a 150% increase in just a matter of days. Such behavior reflects the combination of limited supply, high demand, and cultural perceptions of technology as both a functional tool and a status symbol. Secondary market dynamics reveal not only speculative behavior, but also the social desirability associated with being an early adopter of cutting-edge AR technology. Individuals are willing to pay substantial premiums to signal technological sophistication and participate in the first wave of immersive AI-driven experiences. The emergence of short-term rental services, charging 600 yen per day to experience the glasses, further highlights the monetization of scarcity and access. Consumers who cannot secure purchase opportunities are willing to pay for limited-time interaction, demonstrating a willingness to invest in experience over ownership. This phenomenon parallels historical trends in consumer technology adoption, such as the early iPhone and PlayStation launches, where scarcity and hype created secondary markets, social status incentives, and temporary price inflation. From a business perspective, the market frenzy provides valuable insights into demand elasticity, pricing strategy, and global market segmentation. Meta can leverage these observations to plan production, optimize inventory allocation across regions, and evaluate the potential for localized partnerships and pricing adjustments. Additionally, understanding secondary market behavior can inform strategic decisions about limited edition releases, bundled products, or rental programs, ensuring sustained consumer engagement and revenue growth. Economically, the frenzy illustrates broader dynamics in emerging AR and AI-powered technologies. The intense demand underscores public recognition of the utility and entertainment potential of AR applications, from navigation, communication, and gaming to professional productivity tools. The market response suggests that AR is beginning to transition from experimental technology to mainstream adoption, with significant commercial implications for software, hardware, and content ecosystems. However, this enthusiasm also comes with risks. Supply constraints, logistical challenges, and over-reliance on early adopters could limit the broader market penetration. Additionally, elevated secondary market prices may create consumer frustration or perceptions of unfairness, potentially impacting brand reputation. Meta must carefully manage supply and messaging to maintain long-term consumer trust while capitalizing on initial market excitement. In conclusion, the second slide highlights the intensity of the market response, global sellouts, speculative secondary pricing, and emerging consumer behaviors. This stage represents a critical inflection point in the adoption lifecycle of AR technology, providing valuable lessons for product strategy, market management, and long-term ecosystem development. The Rayban display. AR glasses are not just a consumer gadget. They represent a significant milestone in augmented reality technology and human-computer interaction. At the core of their appeal is the integration of high-performance hardware with advanced software systems, creating a new paradigm for how humans can interact with digital content. The device employs a single-eye LCOS, liquid crystal on silicon, microdisplay paired with waveguide optics. This combination enables high-resolution imagery at 600 by 600 pixels and a peak brightness of 5,000 nits, ensuring usability even in bright outdoor environments. The optics are designed to overlay digital information seamlessly onto the wearer's real-world view, bridging the gap between virtual and physical reality. Equally transformative is the inclusion of the Meta Neural Band, a sophisticated input system that reads surface electromyography (SEMG) signals. By interpreting subtle muscle movements in the user's hand and fingers, the glasses can execute commands and manipulate digital content without the need for traditional controllers. This level of intent-based interaction is revolutionary because it enables a near mind-like control, where the device responds directly to user intentions. The neural band represents a culmination of research from Meta's acquisition of KeyRL Labs, an R&D effort that cost over $500 million and spanned several years, emphasizing the scale of investment necessary to achieve meaningful AR interactivity. From a human-computer interface perspective, this technology significantly reduces the friction associated with traditional input devices such as keyboards, touchscreens, or VR controllers. The potential applications are vast. Users could interact with productivity software, gaming environments, navigation tools, and communication platforms in a way that feels intuitive and immersive. For businesses, the glasses open doors to enterprise AR applications, including remote collaboration, design visualization, and real-time data overlay in industrial settings. For consumers, the combination of portability, simplicity, and immersive capabilities offers entirely new ways to experience media, social networking, and gaming. The glasses also exemplify the broader convergence of AI and AR. Machine learning algorithms are employed to interpret EMG signals accurately, predict user intentions, and adapt system behavior in real time. This allows the device to function effectively across different users with varying physiology, muscle patterns, and interaction styles. Such adaptive systems are crucial for ensuring a positive user experience and minimizing frustration, which is often a barrier to the adoption of early AR devices. Furthermore, this integration of AI with physical hardware highlights a key trend in emerging technology: intelligent interfaces that seamlessly bridge digital and real-world interactions. Economically, the sophistication of the hardware and software translates into strategic advantages for Meta. By combining unique proprietary technologies, the company establishes high entry barriers for competitors, while simultaneously positioning itself as a market leader in consumer AR. This technological differentiation not only justifies premium pricing, but also drives secondary market excitement, as observed in the resale surges in China and other regions. Moreover, Meta's focus on a single-eye display with modular software improvements allows for iterative hardware upgrades without necessitating entirely new devices, potentially reducing manufacturing costs and extending product lifecycle revenue. Beyond immediate commercial implications, The technological achievements in the glasses provide a foundation for future AR and mixed reality XR development. Innovations such as the neural band, advanced waveguide optics, and ultra-bright microdisplays create a platform that other developers and content creators can build upon. Meta's Reality Labs strategy emphasizes long-term R&D investment rather than short-term hype, and the release of these glasses demonstrates the tangible payoff of such a strategic approach. This positions Meta not just as a consumer electronics manufacturer, but as a central hub for the evolving AR ecosystem. In summary, the third slide underscores why the Rayban display AR glasses represent more than a novelty. Their technological sophistication, AI integration, and human-computer interface innovations signal a step change in AR capabilities. They provide both immediate consumer excitement and a long-term foundation for Meta to lead in XR innovation, enterprise applications, and AI-enhanced immersive experiences. These factors collectively establish the product as a significant milestone in the trajectory of augmented reality technology. The Rayban display. AR glasses are the product of over a decade of sustained research and investment by Meta, tracing their lineage back to the early Oculus 5R experiments in 2014. From the very beginning, Meta, formerly Facebook, recognized the transformative potential of immersive technologies to redefine human interaction with digital content. Over the past 10 years, the company has invested billions into hardware development, software systems, and AI integration. This long-term commitment contrasts sharply with competitors who often focus on short-term market opportunities rather than foundational technological advances. Key to the development of these glasses is the acquisition of CTRL Labs in 2019, which brought in neural signal reading technology. This allowed Meta to pioneer the neural band, capable of interpreting subtle muscle signals to facilitate intent-based control of AR content. The acquisition represented not only a technological breakthrough, but also a strategic bet on the integration of AI and neuroscience into wearable technology. Over the years, multiple iterations of hardware prototypes, optical solutions, and software refinements were tested, often in parallel, to ensure scalability, reliability, and user comfort. The extended R&D process reflects the broader philosophy that meaningful innovation cannot be rushed. Hardware, optics, and software needed to converge seamlessly to create a device that was usable outside controlled laboratory environments. Meta's Reality Labs invested heavily in computational modeling, materials science, and human factors engineering to ensure that the AR experience was both functional and immersive. These years of incremental progress culminated in a device that now provides both commercial viability and a compelling user experience, demonstrating that patient, long-term R&D yields tangible results. Moreover, the decade-long effort highlights the challenges inherent in AR development. Consumer expectations are high, and early products often suffer from usability issues, bulkiness, or suboptimal interaction models. Meta's approach of integrating the neural band, waveguide optics, and AI-driven gesture recognition addresses these challenges, creating a product that not only works, but also sets a new standard for what AR glasses can achieve. The investment of time, capital, and human expertise underlines the notion that transformative consumer technologies require not just vision, but disciplined execution over multiple years. Economically, this extended R&D investment positions Meta as a leader in the XR ecosystem, capable of leveraging proprietary technologies to maintain competitive advantage. The company's long-term strategy has resulted in a product that commands premium pricing, drives secondary market excitement, and generates consumer and investor confidence in Meta's capacity to deliver future innovations. Additionally, the sustained focus on iterative development creates a platform for future enhancements, including dual-eye displays, higher resolution optics, improved neural input, and expanded software ecosystems. From a societal perspective, The decade of development demonstrates the importance of patience and persistence in technology commercialization. Early hype often obscures the underlying challenges of engineering complex systems. Meta's approach provides a model for how large-scale innovation can be structured. Heavy upfront investment in research, continuous iteration, and careful alignment between hardware, software, and user experience. This methodology may inform other companies pursuing emerging technologies, particularly those at the intersection of AI, AR, and human-computer interaction. In conclusion, the fourth slide emphasizes the historical and developmental context of Meta's AR glasses. The decade-long journey from Oculus to Reality Labs, combined with strategic acquisitions and sustained R&D investment, has resulted in a product capable of transforming human interaction with digital content. This history reinforces the importance of long-term vision and disciplined execution in producing meaningful technological innovation. The launch of Meta's Rayban display AR glasses has prompted widespread discussion about whether this represents AR's equivalent of the iPhone moment, signaling the start of mainstream adoption and a transformative shift in how humans interact with technology. While the device introduces a compelling interface, intent-based gesture controls, and advanced optics, it is important to contextualize the product in the broader evolution of AR technology. Some analysts argue that, like the first iPod, it is an important early product that lays the groundwork for future, more refined consumer devices. It demonstrates feasibility and market interest without necessarily signaling the maturity of the entire AR ecosystem. The glasses provide intent-based interaction where the user's neural and muscle signals directly control digital content. This is analogous to how multi-touch revolutionized smartphones. But in its current form, the glasses represent the first iteration of a new input paradigm rather than a fully refined user experience. While highly innovative, early adopters may encounter limitations related to single-eye display, field of view constraints, or user acclimatization. Despite these challenges, the device's ability to translate subtle gestures into digital actions marks a significant technological breakthrough, demonstrating the potential of AR to become an integral part of daily life. Meanwhile, competition is accelerating in China, where companies such as Thunderbird, Rokid, and Inmo are developing dual-eye micro-LED AR displays. These competitors emphasize higher resolution, immersive dual-eye experiences, and alternative neural interfaces. The global race for AR supremacy is not just about hardware. It involves software ecosystems, developer engagement, and content availability. Meta's first-mover advantage in consumer intent-based AR must be leveraged carefully to maintain leadership as rivals advance quickly. Economically, the launch highlights the interplay between innovation, scarcity, and market perception. Rapid sellouts, high secondary market prices, and rental services indicate strong consumer interest and willingness to pay for early access. However, the premium pricing and limited availability suggest that broader adoption will require subsequent product iterations that balance affordability, usability, and content ecosystem development. Meta's strategic challenge will be to convert early enthusiasm into sustained engagement, ensuring that the AR glasses evolve from a novelty product into a platform that delivers long-term utility and social adoption. Culturally, the glasses signify the merging of digital and physical experience. As AR integrates more seamlessly into daily life, it may influence social interactions, educational practices, entertainment consumption, and professional workflows. The glasses act as both a technological tool and a social symbol, with early adopters participating in a status-based adoption curve that signals technological sophistication. Managing this social perception will be critical as Meta scales the technology and addresses global markets with diverse cultural expectations. In conclusion, the fifth slide emphasizes that Meta's Rayban display AR glasses represent a pivotal early moment for AR technology, analogous to the first iPod or the first iPhone in their respective domains. While the device demonstrates transformative capabilities and market potential, it is the foundation rather than the culmination of AR innovation. The product's success, future iterations, and competitive positioning will determine whether this truly becomes the mainstream AR breakthrough that transforms computing, human interaction, and digital life.